Grab a flashlight, turn it on. You see a beam of light. Simple, ordinary. You've done this 1,000 times. But let me ask you something you've probably never thought about. What is that beam? Is it a wave like a ripple spreading across water? Or is it a stream of tiny bullets, little particles shooting through space? Scientists argued about this for centuries. Turns out the answer is way stranger than either side imagined. Light isn't a wave. Light isn't a particle. It's something that has no name in everyday language. And the proof? One experiment changed everything. It's called the double-slit experiment. And honestly, it's the most unsettling thing in all of science. Not because it's complicated, because it's simple and the result makes no sense. Picture this: a wall with two narrow slits cut into it. Behind the wall, a screen. In front of the wall, a light source. Simple setup. 3 things, that's all you need. Now, if light is made of particles, you'd expect this. Shoot them at the slits, and they go through like bullets. 2 bright stripes on the screen, 1 behind each slit. Makes sense, right? But that's not what happens. When you actually do the experiment, you don't get 2 stripes. You get this. Bands of light and dark alternating across the screen. This is called an interference pattern, and it only happens with waves. When 2 waves overlap, they amplify each other in some spots and cancel out in others. So light is a wave. Case closed, right? Not so fast. Here's where it gets weird, really weird. What if you turn the brightness way down and send just 1 photon at a time? 1 tiny particle of light. It goes through 1 slit, it can't go through both, right? It's 1 particle, and it hits the screen. A single dot. You do it again. Another dot. Again. Another. But after thousands of photons, 1 at a time, you step back and look at the screen. And there it is, the interference pattern, bands, the wave pattern. But each photon went through alone. Each photon went through 1 slit, alone. There was no second wave to interfere with. And yet the pattern says it interfered with itself, as if it went through both slits at the same time. So scientists thought, fine, let's settle this. Let's put a detector at the slits. Let's actually watch which slit each photon goes through. And that's when everything broke. The moment they watched, the interference pattern vanished. Gone. Instead, 2 plain stripes, as if the photons knew they were being observed and changed their behavior. Turn the detector off. Stop watching. The interference pattern comes back. Turn it on again. Pattern disappears. Off, pattern, on, no pattern. Every single time. And before you ask, no, it's not the detector bumping the photons. Scientists have checked this every way possible. The detector doesn't touch anything, it just watches. And watching is enough. Think about what this means. A photon, traveling through space, behaves like a wave exploring every possibility at once. But the moment you look at it, the moment you ask, which slit, it picks one. It becomes definite, real. It's as if reality is shy. It doesn't decide what's happening until someone checks. Until then, every possibility exists at the same time. Not we don't know which, all of them, at once. No one fully understands why this happens. Not Einstein, not Feynman, not anyone alive today. It's the deepest mystery in all of physics. The universe doesn't decide what's real until someone watches. Next time you catch yourself staring at something, a candle flame, a streetlight, a star, remember, you're not just looking at it, you're making it real. The universe is watching you, watching it. If any of that just made your brain tingle, hit subscribe and tap that bell, because trust me, next time, it gets even weirder. Mom, guess what I'll learn next?